Hello everyone, welcome to Lab 4. In this video we will keep working and we will keep talking about visual analytics, but this time instead of Python we're going to learn how to use R. Okay, so in R the most powerful library for plotting is ggplot2. So in order to be able to use ggplot2 in our notebook, the first thing that you need to do is you need to go to runtime, change runtime type. So the default here is Python 3. So you will find this. And you need to change it to R. So now Colab is going to be able to understand that the code that you're using is R, an R code. Alright, so for ggplot2, for this library, we will need to install a package. It can be ggplot2 or the tidyverse, which has different and multiple packages that are really useful when you are doing that analysis using R. Now, in ggplot2, there are some key concepts that you need to understand so you can use the function and plot what you want to visualize. Okay, so the first thing that you need to know is, okay, which is the data set that you want to use. So we need to provide to the function the data set. Then we have the aesthetics part, the AES, the aesthetics. So it's a way to map the variables. So here we specify which variable is going to the x-axis, if needed to the y-axis, or even we can add some categorical variables to the color, to the shape of the points, and things like that. So in general, you will add x and y, and in some cases you will add more variables. That depends, of course, of the problem, the context. Now, in addition to the aesthetics, we need to provide the geom. So there are different geoms here: geom points, geom lines, geom bars, and that's pretty much how the plot is gonna display the information. So in ggplot2, we work using layers. So first we provide data, and then we start adding layers to visualize the observations, and also you can add like additional lines or to customize the plot, like using the multiple layers. Alright, so the basic structure that we're going to use in this video is the following: the name of the function ggplot, parentheses, then data, that's your data set. The aesthetics part you need to provide in the y-axis, in the x-axis, which is the variable, and the y-axis, which is the variable. It depends, if, of course, if you're going to visualize a single variable or two variables or more. Then the plus sign, we add geoms, geom line, geom bar, geom box plot. That's where you define which type of plot you want to use. Then the theme, which is this is optional. There are different themes. They are going to change the way your plot looks, the colors, the grids, and things like that. The labels, of course, if you want to change x, y axis, and the title. This is the common geom layers, or the geom point for a scalar plot, geom line for a line plot. This is typically used when you have a time series. Geom bar for bar plots, geom histogram, geom box plot, and geom smooth. This one, it's sometimes when you have a scalar plot, you want to show that there is a train. There is like a train. You need a train line to visualize that. So you can add a linear regression using a geom smooth. Okay, so let's get started using ggplot2. So the first thing is to install packages. So here you can install just ggplot2, or I prefer to install the tidyverse because it has more packages and we will use different data sets, so it's better to just have like the complete tidyverse available. So once we start the tidyverse, we need to load the library. It's similar to, remember, in Python when you import the library. So here we just call the library and the tidyverse. Alright, so it's installing. is ready. Now we have different data sets available from the tidyverse. So let me just show you one that is popular, the MPG is miles per gallon. So this data set, I'm sure that some of you have used this data set. It's typically used to analyze a car's efficiency. So we have the manufacturer, like Audi, Chevrolet. Then we have the model, the displacement. This is a metric that gives you an idea of how big is the engine, the car engine. So the bigger the car engine it has more power. The gear, number of cylinders. Now some variables that are interesting for us is a HWY, highway, and city. These are like the number of miles per gallon in highway, number of miles per gallon in city. So it measures the efficiency of the car. We have the class, if it's a compact car, minivan, SUV, mid-size. Okay, so let's create some examples here. Let's count, let's visualize the number of cars by class. So we use ggplot, that's the function, the name of the dataset, MPG, then the aesthetics. This one has a single variable, it's a bar chart. So here in the X we'll see the class. Now if I leave it like this, we'll get an empty plot. Because so far I have provided data, I know where it's going to the x-axis, but I haven't mentioned what type of layer I want to use to visualize the data. So that's what we're missing, the geom layer here. So plus, we need a geom bar, because it's a bar chart. So now ggplot2 knows how to represent our data, because it has the data, the data set, it knows which variable is going to be used in the x-axis. Then once we give the geom bar instruction of that layer, immediately we are able to visualize our plot. So now we can see that in that specific in our data set, most of the observations or most of the cars are SUV, right? So let me show you. There are different geoms. So for one variable which is continuous, you can use geom area and geom density. Remember the density plots, dot plots, histograms, QQ plots. If it's discrete, there are different alternatives. If it's continuous, two variables, both are continuous. We can use here a geom smooth. We have box plots for one discrete and one continuous. And you see there are multiple options. It depends, of course, of what you're trying to visualize and analyze. All right, let's continue. In the second example, we want to analyze the highway miles per gallon. So we want to analyze that only that variable, which is a continuous variable. So we will use a histogram for that. So we use the ggplot, MPG, our dataset. For the aesthetics, the x variable is going to be the highway. And now we need the geom. In this case, we know it's a histogram. Look at all the options that you have here. And now you can visualize the shape of that variable. Please note that there are few cars, like small number of cars in the dataset have an efficiency of more than 40 miles per gallon. So most of them are between, let's say, 15 and 30, I would say. Now you can also adjust the bin size. So here the default is we are getting 30 bins. but you can also change the bin size. So there are different alternatives. One is to change the number of bins, or another alternative is the bin width. I will say like 5 miles per gallon. So now that's the size, right, of the interval for each bin. So it's 5. And again, the conclusion is the same. But sometimes you will adjust that the bin width or the number of bins, so you can see the way your data, the shape it has. All right, let's continue. That was a histogram. Now let's add a box plot of highway, miles per gallon in highway, and the class. So we have a numerical variable, this a continuous numerical variable, and also a categorical variable, which is the class. So ggplot, mpg, statics. In the x-axis, all I have the class, and in the y-axis, the numerical variable, which is the miles per gallon in highway. The geom is going to be box plot. So now we can compare the efficiency of these cars in highway per class, right? So you can see which of these classes have the higher performance or efficiency. So for this, when we're comparing box plots, the first thing I'm gonna look is the median value. So if you notice, the median values for compact and mid-size, these two are, like the higher values here. These two mediums, they look different to, for example, to the pickup and the SUV. There is a high difference. So most likely, that's a significant, statistically speaking, there is a significant difference. But again, if at some point you want to confirm this, my advice is that you should use ANOVA, a Kruskal-Wallis test, hypothesis testing, pretty much to verify if they are different or not. Now, in addition to the median value, which again in this case there are some clear differences for sure, we also check the variability. Now, when you check the variability or the dispersion, look at the boxes, like how tall they are, and also the whiskers, like the distance between the minimum value and the maximum value of the whisker. So that gives you an idea on how, like how much uncertainty you have in that specific class. In this example, we look at two-seater, minivan, and pickup. They have an equivalent variability, small in general, but in this specific case, compact vehicles, they have a higher variability compared to others. At least this is just based on my exploration. All right, let's check example number 4. We want to analyze displacement, which is again related to how powerful is the car engine and the efficiency. So ggplot, data, statics. So we know here displacement and the efficiency is the result. Here we want to create a scatter plot. Remember that we use scatter plots to visualize the relationship between variables. If there is a linear relationship or non-linear relationship, or they are not related at all. Geom point. All right. Now you can see that it looks like there is a trend, right? There is a trend. So as the displacement increases, as the engine is bigger and more powerful, then the efficiency or the number of miles that the car will cover per gallon decreases, right? And actually the relation looks a little bit linear. It has some variability, but in general it looks linear. We can also add some trend lines. That's an alternative here. So we can add more layers. So GeoSmooth. Is adding a trend line. So please notice that it's linear up to some point, but then there is like a non-linear behavior. And if you wanna, I'm using the default here, but it's possible to define the method. If you want a linear approximation, so method, we use LM, the linear model, and then we get a trend line which is based in a linear regression. In this case, that's a simple linear regression because we only have two variables, the miles, which is the y, and the displacement, that's our x. All right, so far we have used the same data set, this MPG, but there are more options here. For example, here there is in the tidyverse, there is an economics data set with information of unemployment. But please notice that there is a big difference. In our original example with miles per this one, the cars, the order in this data set is not relevant. It doesn't matter if you have the Audi at the beginning and the Chevrolet. If I change positions for these observations, if I kind of like randomly rearrange this data set, it won't affect my plots. They will be the same. But in the case of the time series, you cannot do that. The order matters. Like in this one, in this example, in this data set, this is a time series. So this unemployment information, it has a timestamp. We have a date. So this is per month, it looks. Let's see. Yeah, it's a monthly information. So it's important to ensure that we don't mix the data. So to visualize, let's visualize the unemployed. And to visualize a time series, typically you use just a line. You don't need more than that. So ggplot, economics, that's the data set. For the statics, for the expiring, I'm going to use date. And for the y variable, I'm going to use the unemployed. So it's not showing the information. It's giving the information of x-axis, y-axis, but again we're missing here the geom, right? So let's add geom line. Again, this layer is the one where you define how do you want to visualize the data. Using a line, right? That's the name of the geom. So now we can see the time series, the way it behaves. So you have increasing. There are some. This is not random. There is some seasonality. Yeah, you need to understand that better to see why it's having like that. You know, it increases then decreases, increases then decreases. That's not randomly. But it's important to see what's the reason. So most likely there are some economic cycles, right? Like every 10 years, that will show us. Yeah, they look like every 10 years. I don't know. But again, you have to go deeper in your data to understand why it's behaving in this way. And also you need context. Maybe with some context we can know, okay, what specific events at that moment kind of like were affecting the unemployment rates. Okay, now let's do a case study. So in this one, we want to analyze the customer purchasing behavior. So the context is a retail company wants to understand its customer purchasing behavior to improve sales strategies and customer satisfaction. The data set includes customer demographics, spending habits, regional differences, and payment preferences. The objective is to analyze patterns and trends that can help optimize marketing efforts. So there are some questions like what is the age distribution of customers? How does annual income correlate with average purchase value? Are there any significant differences in customer satisfaction across different payment methods? How does gender distribution vary across regions? Okay, so let's read our data. You will find it on Brightspace. I already uploaded information, but you have to, same thing as we have done in previous sessions. You need to find where your file, customer data, upload it. It will be available here. If needed, just copy the path. Now here I'm not using pandas, right, because we have R, but it's really similar. So instead of pd.read CSV, now we have read.csv. We read our data, we get the data set, we know the customer ID, the age, gender, annual income, total purchases, the average purchase value, customer satisfaction, and preferred payment method and the region. All right, so what is the age distribution of customers? Age here is a numerical variable, so we can use here a histogram to visualize age. So remember the structure, similar. ggplot, the function, the data set, right, customers. For the statics, I'm gonna use the variable age in the x-axis, and let's use a histogram. This is optional, so this is to add labels. The title, distribution of customer ages, x equal to age, and y equal to count. So here, we're getting a histogram, right, where we can see how the ages of the customers are distributed. So I can change the bin width. I'm going to use 5 years. Now, this is the important part, interpretation. Remember, nowadays, it's really simple to create the plots, the code. The coding part is getting easier, right? The interpretation is where you add value. So here we want to understand our customers. Now, imagine that we are, like analyzing this data in the context. So the question, let's say the one question is, which are like our most important customers? What's their age? So looking at the plot, we can see like our customers, like most of our customers are between 25 and 50 years, even 45 years, right? They are focused here. They are in this area. Because imagine that someone is, okay, no, we should focus entirely in customers above 50 years. Well, if you wanna like keep your customers, then maybe that's not a good strategy, because that's not where you have the volume of your customers, unless you are targeting like to increase the sales in some of the demographics in some of the ages that are not buying enough right now. So in that case, yeah, that will make sense. So it depends of the needs of the company, of course. Okay, the second question is, how does annual income correlate with average purchase value? So two numerical variables, then we need a scatter plot, right, to check if there are differences. So ggplot, customers, statistics, the x is the annual income, one of the variables, and the second variable is the average purchase value. So we want to see if there is a relationship. Then we use a scatter plot with geopoint, and we're adding the GeoSmooth, as we did in one of the examples, to see if there is a relationship. So clearly you see that as the annual income increases, the average purchase value increases. It makes sense. And the relationship looks linear, even though there is variability over here. You can see that it had the shape, it's almost like a straight line. So yes, there is a clear linear relationship between these two variables. Okay, question number 3. Are there any significant differences in customer satisfaction across different payment methods? So we want to compare the variable customer satisfaction, is from 1 to 10, and the customer preferred methods. So that's a numerical variable and a categorical variable. For that, you can use a box plot. We have done it in the past. Remember with the miles per gallon per class, same thing, same idea. So here we create our plot, customer satisfaction, the y-axis, and preferred payment method. We have cash on delivery, credit card, or PayPal. when we check when we look at the medians, the PayPal median looks higher, the satisfaction looks higher, right, compared to the others. However, since when you are analyzing these plots, please notice that there is some overlapping between the boxes, right? There are not like huge differences. They are kind of at the same level, even though PayPal is higher, the median. You have to be careful here. If you wanna like make a conclusion, my advice is to use hypothesis testing here. Like the mean comparison using ANOVA. That would be a good idea here, instead of just making a comparison just by looking at the plots. This is helpful because it gives you an idea, right? But at the end of the day, if you're not really confirmed, you need a statistical method to do that. Now, in terms of the variability, in PayPal we have higher variability, and maybe that's one of the problems here too. The mean comparison is not going to be that easy because the variability is high. So there is a high chance that they are going to be the same after the testing. Okay, now let's go to the last question. How does gender distribution vary across different regions? So we want to compare the gender distribution. So ggplot customers, we use X region, and we're filling by gender. We use the geom bar. Now the nice thing about these bars that we have created here is that the scale is from 0 to 1. So it's we're using proportions here. So we know per region is north, south, and west. We can see there are some differences. Now they look similar. However, in the north region, for example, the male percentage or male proportion is smaller compared to the others, at least just by looking at the plots. And the female percentage is higher compared to the regions in the north, right? And in addition, the other, it's also a little bit higher in the same region. So that will be my conclusion here. Of course, you will need to go to validate that, if that makes sense, but that's just variability right there. Okay, I'm gonna stop the video. I hope you enjoy creating plots using R. In general, I will give you freedom to pick like the software that you want, but most of our classes will be using Python. However, it's important that you know how to use R because it's another tool in your toolbox. All right, I'll see you in our next session.